Let's go through Lico 3228. Max the number of operations to move once to the end. For this question, it gives us a string S, and we can perform the following operation in the string any number of times. Choose any index I from the string, which have I plus 1 smaller to S dot length, and Si equals 1, and Si plus 1 to 0. So that is we have this kind of Si and the Si plus 1. We need to move the Si to the right until it reaches the end of the string or another 1. So for example, 0, 1, 0, 0, 1, 0, right? So what we do is that if we move this 1, right, we can move to here. Right. So if we move this one, right, then we can move this 1 to here, and then this becomes to 0, and then we can move this 1 to here, right? So it need will return the maximum number of operations that you can perform, right? So if we want to get the maximum number of moves, what we do is that we go through left to right. If we find this kind of 1, 0 operation, right? So then we move this one to the first one on the right. So it is here, right? So let's look at the operations for the first example. Okay, so it will be 1, 0, 0, 1, 1, 0, 1, right? So what we do is that we move this one to here, right? So it become 0, 0, 1, 1, 1, 0, 1, 0, 1. So this is one move, right? And then the second time is we move this one here. So it become 0 here, right? And 1, 1, 0, 0. So these 2. And the third is move. Sorry, this is 1, 1, 1, 1, 0, 1. This 3, right? And the fourth term is that we move this 1, 1, 1, and move this one here, right? So it should be, so you can need 4 terms. We can move maximum that for 4 times. If we want to ask what's the minimum, right? We just move on right. If there is a 0, it's right. Move this one, count how many ones, right? So that we move, that will be 3, right? But for maximum is we just simulate the issue, the steps. If there is 1, right, we just we count how many ones here. We already have 1, 1, right? And if there is a 0, we can in the previous one is a 1. We can add those kind of ones to our results. So now our ones is 1, right? And then we move this 1 here, right? Then we go step to here. There are 3 ones, right? 3 ones. Then we find another 0. What we do is that we should add these 3 to our results, right? Because everyone we need to have can have perform a move, right? So that is the result should plus 3, right? So so result plus 1 plus 3, that is the 4. So let's write code for this. Let's have char array equals s dot to char array, right? And we're going to have int n equals array dot length, and we are going to have ones equals 0, result equals to 0, right? So for int I equals 0, I smaller than n, I plus plus. If array I equals 1, right? So we'll have ones should increase our ones, right? So we'll say if array if I greater than 0 and array I equals 0 and array I minus 1 is 1, right? In this case, our result should plus equal to 1, right? once, and in the end return the result. And Python code should be very similar. What we do is that we have once result equals 0, 0, right? So what we do is that for I in range length s, right? So if s I equals 1, right? Then we'll have once should plus equal to 1. And we'll say if s if I is greater than 0, and si equals 0, and si minus 1 equals 1, right? Then we'll have result should plus equal to once. Then you then return result. The time complexity for this invalid syntax. If in range length as once, so line 7, if I si equals this is 0 and si minus 1 should be end, right? And, okay. It's O(n) time complexity.